joints, those are all types, meaning examples of joints. Okay, but how do you classify joints? On what basis?
Which eject?
Basis.
Hmm?
How the bones are joined together, like.
Yeah. First of all, why do we need joints? Can we turn up the phones,
move
please?
your arms.
As we speak.
Connect bone and muscle bone.
Hmm?
Connect bone to bone.
That's all? Then what
And
do we
like-
do?
Help us move.
Yeah, movement. Right? You need to get there to the destination, otherwise you'll be stuck halfway in the traffic. So one characteristic is movement. How much they move. They move, they don't move a little bit, more, or very freely. Okay? No movement. You can see the very first one, bony joints, it says synostosis. The bony joints. This is how the bones are made. What kind of joints they are. Then very little to no movement depending on the case. You have, what do you call the next one, the fibrous joints? Synoarthrosis. Okay, these are your fibrous joints. And the most freely movable, we call that what? Synovial. But there is a name for that. Synovial will come here. What is that? Diarthrosis. And the joints that are in between these two, they are relatively more movable compared to this and less movable compared to this. What do we call that? So your cartilaginous joints will come under that category. So synostosis, you don't see even any markings where the bones are joined. Like for example, frontal bones, mandibular bones, when they are in the process of formation, they remain separate, but they fuse into one bone. Like sacrum coccyx, you see the lines, right? But you don't see that in the frontal bones or in the mandible. In the maxilla, you see the suture. Okay, so the first one is the bony joint. Those examples are discussed in that section under bony joints, if you did look up, or you can still do that. And then in the synoarthrosis, which is made by fibrous joints, you have three types. Like in the sutures, that's one kind, sutures on the skull. If you have your book, please turn to your page, figure 9.2. I don't have to say that. And the second kind is in your tooth, in your mandible, connected to the mandible through fibrous connective tissue. They call it gymphosis. And then the membrane that you find connecting the bones in your arm, especially the forearm and the lower leg. What bones are connected in the forearm?
The humerus, radius, and
Forearm,
the ulna, and the
radius and ulna. What about the lower leg?
tibia,
Tibia and fibula. So they call that, even there's a name for that, they call it interosseous membrane. that fibrous tissue that connects those bones in the arm and the leg. So those are the three types of fibrous joints which are categorized as the syn-arthrodial joints. Figure 9.2. And then the sutures can be of three types. The sutures, sometimes they are overlapping, or they are plain, meaning they don't overlap, or they have those wavy lines. We call it serrate. You have three kinds of sutures: the serrate, lap, and plain sutures. Then coming to the next one, the cartilaginous joint, which is amphiarthrodial or amphiarthrosis. They give some movement, like your cartilage in between the rib bones. The costal cartilage is made up of hyaline cartilage. That falls under this category. They have separate names for the one that you find on the rib cage and the one that you find between the pubic bones. The one that you find in the rib cage relatively allows more movement compared to the pubic bones, because you don't want too much movement down there in the pelvic region. So the first one they call synchondrosis, figure 9.4. It's made up of hyaline cartilage. There are three types of cartilage: hyaline, elastic, fibro. So this is the hyaline cartilage. And the other one, which is made up of fibrocartilage, which is called the symphysis, like, for example, pubic symphysis. Even your intervertebral disc is made of fibrocartilage. Give you a couple of minutes to look up that if you didn't, and also look up the figure for synovial joint. The description is on page 283 and the figure is on 284, figure 9.5. Give you a couple of minutes and then we will discuss the synovial joint. This is your thigh arthrodial joint. There are several examples. Most of the synovial joints, if you see in figure 9.5, you have a typical synovial joint. What are the structures that you find there? You have a cavity of space in between the bones that come in contact with each other. The cavity is your synovial cavity. It's filled with a fluid called synovial fluid, and the cavity is made by the innermost layer, which is the synovial membrane, and on the outside you see what? Fibro capsule or fibrous capsule is made up of the fibrous connective tissue. And the same capsule becomes your ligament outside the joint. Can you see that? I know everybody is on 4 different pages, even if I give you the number. Figure 9.5, you should at least know where your synovial joint is if you did read before class. And the caption is there. What more can they do? I should have a remote that turns your books to the page. So, yes?
What exactly is happening when you crack your knuckles?
I have no clue. I am not a physician. I wish I... See, the clinical questions I cannot answer. Otherwise, I wouldn't be doing this class.
Air pockets.
Okay.
in your joints.
Maybe. I don't want to say unless I'm an authority on that. I don't want to give wrong answers. So you can accept whichever answer you get. Yes. Okay. The cartilage, the fibrocartilage becomes your ligament, as you can see. All right. So together they call it the joint capsule, which includes your fibrocapsule and the synovial membrane. And then on the bone itself, you have a thin layer of cartilage. What do you call that? Articular cartilage. Okay. So you need to know the structures that make a typical synovial joint. So I'll give you a couple of minutes if you want to look them up. Get your clinical questions and answered in your clinical pathology when you do it once you are out of here. Get into those programs. That's why they haven't covered all of that in these chapters. Otherwise, you have something in the last page that's about it. They introduce you, but they don't have the details. The examples of synovial joint, all of these joints you will see on figure 911, but we will get there in a little bit. Ball and socket joint, the pivot joint and all of that. But let's look at a few more terminology in this same page. What is a tendon? What is a ligament? Tendons attach the muscle to the bone, ligaments attach bone to bone. Okay. And then when these tendons and ligaments move about in any joint, if you do it for a long time, then one goes over the other, then you may be ripping off those ligaments, okay, meaning they may go through wear and tear. So in order to prevent that, you have some lubricating structures. They call them bursa or tendon sheath. So you can see the next couple of highlighted words. Can you see the bursa and the tendon sheath? And you can see them in figure 9.6 on the hand. All those green colored structures, it's like a ice pack or something. It's like a pack with some jello, that kind of consistency. You have them located in strategic positions in the joints, so that reduces friction. So the bursa is a little smaller compared to the tendon sheath. Tendon sheaths are more long, going around the ligaments. So you can see both of them in that figure. Now let's go to the page 290, figure 911, where you can see the different examples of synovial joints. For this, you need to know the name. Where do you find this joint? So it's good that they have the pictures. This is not the only place they have given one example. Like ball and socket joint, you have more than in one place, right?
Yes.
So ball and socket joint, that's your obvious one on your hip and shoulder, right? So they call it humeroscapular joint. Ball and socket is a generic term. They also call it humeroscapular because the joint is made between what? Humerus and the scapula. And what about the next one? Pivot joint. So one bone moves around the other bone using it like a pivot, meaning one rotates around the other bone in that cavity. So if you see, you can even think of your atlas axis, the same thing. So here you have the radius and ulna. The head of the radius moves around the fossa in the olecranon process. That's your pivot joint, a radio-ulnar joint. And then if you see on the top, it says hinge joint because it relates to the same bones. So if you see between the ulna and humerus, you have the hinge joint, like a door hinge. It allows one-way movement, either open, close, right? The same way. That's your hinge joint between humero-ulnar, meaning between humerus and ulna. Then you find some joints in the hand, plane joint among the carpal bones, intercarpal joint. Then you find saddle joint where the one bone looks like the saddle on the horse, sits on the other bone. That's trapeziometacarpal, meaning it's between the trapezium and the metacarpal. And then the other one is a condylar joint. It doesn't have a saddle shape. It has a round head that goes into the shallow cavity of the other bone. That's your joint between metacarpal and phalanges. So if you are given any of these names, you should be able to associate with the right kind of joint. Before we move on, I really do expect that you know what's in your book. Meaning where to find what. If you did your homework, please. Okay? Don't look around for everything after you come to the class. Or even when you come and you're waiting and you're gossiping about many things or whatever, talking, conversation, at least use that time to figure out what is in your chapter. So when I refer to some pages or something, you can quickly go there instead of me having some of you on one page, some of you on another page. Even though I give the page numbers, please help yourself and help me. So the next section talks about the various kinds of movements, like flexion, extension, and so on. So when you say flexion, what is it by definition? Bending a joint or reducing the angle of that joint as flexion. Sometimes they call it hyperflexion if you're trying to flex more, which you don't want to do, but they use the term hyperflexion sometimes. You'll see that in some of the figures. Then extension is extending or straightening or increasing a joint, the angle of the joint. That's your extension. And you can have hyperextension, like beyond what you normally extend. If you try more, that's hyperextension. And you can do flexion extension with many different parts of your body. I can flex my fingers too. It's not just my elbow joint. Okay, so don't fix with one thing. Wherever certain movement is possible, they are going to use the same terminology. You can flex your fingers, extend your fingers. Then you have elevation, depression, abduction, adduction. Let's do abduction, adduction. You can look up the description or the picture, whichever works for you. But you need to read the description when you have the chance. So abduction is moving your body part away from the midline of the body. Abduction. The opposite is adduction. So I can do it with my fingers too. That's abduction. That's adduction. Sometimes they use that for other parts of the body too. So you have to understand what is happening there. Then you have elevation, depression, like when you raise your shoulder or drop your shoulder, elevation, depression. Protraction, retraction, if you're moving a body part anteriorly forward from your midline of the body, that's protraction. If you do the opposite, that's retraction. In rotation, circumduction, rotation is just one bone moving around another bone, something like the pivot joint. We saw the radius rotating around the ulna, or the atlas rotating around the axis. Compared to that, when you say circumduction, there's a movement something like this. So you have a conical movement. You have one axis and you are doing this movement. That's called circumduction. Supination, pronation, you should know by now, in the standard anatomical position, what is that position of the palm? Supinated position, the palm facing forward. So when you do this, the supination. When you do the other way around, the palm facing posteriorly is pronation. Supination, anterior, palms facing anteriorly. Then you can see in figure 917, 18 and 19, you can see the different types of flexions and rotation, either with the hand or with the whole body, the trunk of the body, depending on which side you bend. If I do this, that's my lateral rotation, lateral flexion. If I do this, medial flexion. Or if I do my hand like this, medial rotation towards the middle, lateral away, lateral rotation. Then on your hand, the fingers, you can flex, extend, you can abduct, you can adduct, or you can oppose. Opposition, when you touch the fingers one against each other. Then some special movements they have for the foot and the sole. When you, if this is your foot, if you're like standing on your heel, there's plantar flexion. You're reducing the angle at that joint. Or when you do this, you are increasing the angle at that joint. That's your plantar flexion. Your dorsiflexion or plantar flexion, like walking on toes. Then if you turn the soles of your foot inward, they call it inversion. If you turn them away from each other, it's called eversion. Okay. Take a couple of minutes and go over all the figures and see if you can understand the movements. And make sure you read through the description as well when you get the time. The rest of the chapter is about the various joints and the ligaments. That's the most straightforward information in this chapter. So we'll do that in a few minutes.